Good morning. I'm going to cover lesson 83, writing quadratic equations from roots. So first let's review, because this has a lot to do with how we factor. So let's say I ask to factor x squared, that doesn't look like a 2, my bad, x squared plus 3x minus 28 equals 0. So we would set up our little x tool. I've got a negative 28 and I got a positive 3, so that would be positive 7 and negative 4. So my factors are x plus 7 and x minus 4. These are my factors. My solutions are x equals negative 7 and positive 4 because of the zero product property. So I want you to notice the difference. These are my factors. These are my solutions. And to go from factors to standard form, I would just distribute. So today, writing equations is just backwards of factoring. So writing equations from roots or solutions works backwards. So I'm going to do an example and then we'll jump into your lesson practice. So if I tell you that my solutions are 5 and negative 3, so here are my solutions, also known as roots. We're going to work backwards. So instead of ending with my solutions, I'm now working up. So if these are my solutions, let's write our factors. I know that my factors begin with an x, just like up here. And I know that they should be opposite sign of our solution. So if this is positive 5, our factor is negative 5. If this is negative 3, our factor is positive 3. And then I'm going to distribute to get it into standard form. So x times x is x squared plus 3x minus 5x minus 15. So our equation would be x squared minus 2x minus 15. And technically this is equal to 0 because there were roots or there were solutions. So that's it. So we are going to jump into our lesson practice, which is on page 589, starting with part A. And so in part A, they've told us our roots are negative 7 and 3. So the first thing we're going to do is write our factors. So that would be x plus 7 and x minus 3. You can't have an equation without that letter x, so make sure you start with x. Then we're going to distribute. So x squared minus 3x plus 7x minus 21. So our answer is x squared, I'm combining like terms, plus 4x minus 21 equals 0 because it was solved. Okay, so sorry, I'm going to erase this line because it looks kind of messy. Part B, my roots are both positive, so 2 and 3. I'm going to move this up a little bit. So I'm going to write my factors. Since these are both positive in the factor, they're negative, so x minus 2, x minus 3, and they're opposite because they were set equal to 0. Then I'm going to distribute. So x squared minus 3x minus 2x plus 6. So my final answer is x squared minus 5x plus 6 equals 0. All right, moving on. Part C says the root is negative 5. Now, because this is a quadratic, is a degree of 2, and they've only listed one root. I should have 2 negative 5 solutions. So if they only list one, it's that there's a multiplicity factor going on. So if their only root is at -5, there are technically 2 of them. So my factors become x plus 5 and x plus 5. And if you distribute that, you get x squared plus 5x plus 5x plus 25. So you get x squared plus 10x plus 25 equals 0. Moving on. If you want to pause the video and try this one, part D, my root is 4. Now remember, that means a quadratic is degree of 2, so the root must have a multiplicity of 2. So try and set up your factors. So my factors must be, remember, opposite x minus 4 times x minus 4. And if you distribute, then I get x squared minus 4x plus 16 equals 0. So I get x squared minus 8x plus 16 equals 0. Now, the next couple have to deal with complex solutions. And complex solutions come in conjugate pairs. For example, if one of my solutions is 2 minus 5i, then I know that I have 2 plus 5i as a solution as well. If negative 3 plus I is a solution, then its conjugate pair of negative 3 minus I is a solution. If negative 4i is a solution, then positive 4i is a solution. So they always come in pairs. So we're going to do part E. Our roots are 1 plus 4i, which means the other pair, 1 minus 4i, is a solution. So here are our factors. Now remember, I have to start with an x. I'm going to cover this up. The opposite of 1 is x minus 1. The opposite of positive 4i is negative 4i. Next factor, the opposite of 1 is negative 1. The opposite of negative 4i is positive 4i. And when we distribute, the i's will cancel. So we're going to distribute. So x times x is x squared. X times negative 1 is negative 1x. X times 4i, I'm just going to write 4ix. Now distribute the 1, so negative 1x. Plus 1, negative 1 times 4i is negative 4i. Now I'm going to distribute the negative 4i, so negative 4i times x is negative 4ix. Negative 4i times negative 1 is positive 4i. And negative 4i times positive 4i is negative 16, because a negative 4 times a positive 4. And I times I is I squared. So let's start by combining like terms. So x squared, I'm going to combine my negative 1x's, so that gives me negative 2x. Then I should start noticing the i's cancel. Positive 4ix and negative 4ix. Negative 4i and positive 4i. They're gone. Last, I know that I squared is a negative 1, which makes this a positive 16. So if I combine 1 and 16, I get positive 17, equals 0. And that is my equation. One more, because we're going to skip G, is F. So if my roots are 7i and negative 7i. So let's start with our factors. All factors begin with an x. There's no number here, just the imaginary part. So the opposite of 7i is negative 7i. X. The opposite of negative 7i is positive 7i. Then we're going to distribute. So x times x is x squared. X times 7i is 7ix. Negative 7i times x is just negative 7ix. And negative 7 times positive 7 is negative 49. And I times I is I squared. Right when I see the I squared, I'm going to replace that with a negative 1. Negative 49 times negative 1 is positive 49. So these cancel, and my answer is just x squared plus 49 equals 0. For homework, for lesson 83, we're going to skip numbers 8, 11, 16 through 18, and 25. Thank you.